Hello, this is Susan Poss, and I'm continuing to work in Chapter 8, which is all about systems of equations. And we are currently solving systems by graphing the two lines and looking for the point of intersection, because that's the one ordered pair that is common to both equations. All right, so here's another one. This is a special case I wanted to show you. You can see again, I have equation number 1 and equation number 2. I have taken the first equation and solved it explicitly for y. It's got kind of a mess here. Let me highlight this for you. Here's y equals x minus 1. And off of that, I got a slope of 1 and a y-intercept of negative 1. So I'm going to go over here and graph. Remember, we start here. So there's 0, negative 1. And then the slope is 1, and I'll read that up 1 over 1, up 1 over 1, up 1 over 1. So I'm sketching in. Those are all the points on that first equation. All right, so then I went to equation number 2, and again I solved explicitly for y, and you'll see, look at this equation that I got, and think back to what the first equation was, and you'll notice that they have exactly the same slope, and they have exactly the same y-intercept. So when I go in to plot the points on the second line, I'm putting points on top of points. So I'm looking for how many points I have in common here, how many points on the first line are points on the second line, and of course it turns out that there are infinitely many points in common. So this is a special case. The solution here is infinitely many solutions. Okay, so when you get the same overlapping lines. So when that happens, you say, okay, they have multiple points in common, therefore I have infinitely many solutions. Turns out that any point on the first line will balance check in the second line. All right, so that was the first special case I wanted to show you. Let me scroll on down here. I'm going to show you the second special case. So again, you can see I've split it up into equations 1 and 2. You see I've explicitly solved for y. And so I can identify the slope is 5 over 1 and the y-intercept is 11 on the first equation. Same thing on the second. I solved explicitly for y. And again, you can see that the slope is 5 over 1, but notice the y-intercept. It's different. It's not the same y-intercept. So let me plot the first one. I'm going to start here. And this will give me a chance to show you a little trick, because I'm starting up here at 11, which is off my grid. And I'm being asked now to go up 5 and right 1. And I have no grid up there. So I'm going to take this slope and I'm going to write it as negative 5 over negative 1. That's still a positive 5 slope. This would tell me to go down 5, and this would tell me to go left 1. So I'm going to do that. That puts me back on the grid. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. So this first line looks something like that. That's equation number 1. All right, so when I go into equation number 2, remember I'm going to start. Notice that the y-intercept is at negative 6. So there is 0, negative 6. But and again, this time I'll go up 5 and right 1 because I have room to do that on the grid. So if I count up 5, 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5, 1, I'll do it one more time. And I connect those. Whoa, that was not very good. Turned out okay. Here's equation number 2. I get 2 distinct lines. They have exactly the same slope, which means they run parallel to each other. But they have different y-intercepts. Okay, so because they have different y-intercepts, instead of getting the same line that we did before, one line on top of the other, this time we get 2 different lines. These 2 lines never meet, so what do you think the solution set is? Well, this is another one of those special cases, and this solution is no solution because they do not share a common point, and they're not ever, no matter how far I extend these out on a larger grid, they are never going to have a common point. So that's your second unusual case. So down here, let me scroll down to the bottom and do this little quick summary with you. This is what will happen when you're working with a system of 2 equations and 2 variables. You are either going to get lines that intersect, and you get this one solution, an XY ordered pair, or you're going to get parallel lines which have no solution, and the way you recognize that is because they're going to have the same slope, but they're going to have different y-intercepts, which is what we just saw on the previous example. And the third possibility is that you can have infinitely many solutions, and this happens when you graph and you get the same line. This first line will have the same slope as the second line, but it will also have the same y-intercept. So instead of getting 2 distinctly different lines, you will get exactly the same line. So there's your summary of what can happen with these graphing solutions.